Hello student, welcome back to my channel. This is the last day of this chapter, Refraction of Light. At last, we see the numerical in this chapter. For that, we need the formulae used to solve the examples. So first of all, we know that the refractive index, that is denoted by n. The refractive index of first medium with respect to second, denoted by this symbol, is given by the formula, the velocity of light in second medium with respect to velocity of light in first medium. So remember this relation. Now, if we need a refractive index of second medium with respect to 1, then we write velocity of light in first medium upon velocity of light in second medium. So these are the two formulae. Then we define absolute refractive index. Now what is meant by absolute? The second medium is vacuum and first medium, that is a glass, water, or whatever it may be. So if second medium is vacuum, then we denote that refractive index by n. So remember these three formulas. Then we have solved example from the textbook. First example, the absolute refractive index of water is 1.36. Now, first of all, write down the data that is given. The absolute refractive index of water, that is denoted by n, and that is 1.36. What is the velocity of light in water? Now we denote velocity of light in water as v1, and that we need to find. Now since this is a case of absolute refractive index, the second medium is vacuum, and in that the velocity of light is given by 3 into 10 raised to power 8 meter per second. So these are the things that we know. Now write down the formulae. Formula is refractive, that is absolute refractive index of water, that is 1, respect to 2 is velocity in water in the denominator, and in the numerator velocity. Substitute the values. The refractive index is given as 1.36. Now, what is the value of V2? The velocity of light in vacuum, that is 3 into 10 raised to power 8 meter per second. That is not necessary. Upon V1. Now cross multiply. V1 is equal to 3 into 10 raised to power 8 upon 1.36. Now we need to divide the numerator by denominator. So remove the point from the denominator. So we do one trick, write down the number without this point. Now after this point we have two digits. So write down 20 in the numerator and then 10 raised to power 8. Now do actual division 136 and 300. The actual division, on simplifying, we get the coefficient as 2.21 into 10 raised to power 8 meter per second. So finally we write answer as velocity of light in water is equal to 2.21 into 10 raised to power 8 meter per second. Now second solved example, that is light travel with a velocity 1.5 into 10 raised to power 8 meter per second in a medium. So first of all write down the data that is given. So velocity in first medium 1.5 into 10 raised to power 8 meter per second. On entering second medium, it velocity becomes, so velocity in the second medium is given as 0.75 into 10 raised to power 8 meter per second. What is the refractive index of second medium? So for 2 and 1 is how much? So to solve we need formula related to these three things. The refractive index of second medium with respect to 1 is given by, now velocity of light in second medium in denominator and in numerator velocity in first medium. Now substitute the values. Now what is V1? That is 1.5 into 10 raised to power 8 meter per second. Not necessary to write the unit because they are same. 0.75 into 10 raised to power 8 meter per 10 raised to power 8. 10 raised to power 8 get cancelled and we left with 1.5 upon 0.75. Now how will you solve this? Again last trick. So write down the number as it is and then in the numerator, since point after the point decimal point there are two digits, so write down 20 in the numerator. In the numerator we have one digit after the decimal point, so one digit, so 10. Now this 00 get cancelled. Now this is simple division of 150 by 75 and we know this is 2 times 150 is 2 times the 75. So this is the refractive index. So what is answer? A refractive index of second medium with respect to first medium is 2. There is no unit, so remember this. Now we solve the example from exercise. First example, that is A. If the speed of light in a medium is 1.5 into 10 raised to power 8 meter per second. So what is given? Given that the speed V1, that is 1.5 into 10 raised to power 8 meter per second. What is the absolute refractive index of the medium? So what is N? We need refractive index of medium. Now whenever we talk about absolute, the second medium is vacuum. So write down the velocity of light in vacuum. This is a standard value, that is 3 into 10 raised to power 8 meter per second. Now what is the formula? Write down the formula. The refractive index of medium with respect to vacuum. So medium is V1 and vacuum is V2. So velocity in vacuum V2, velocity in medium V1. So substitute this value. V1, V2 is 3 into 10 raised to power 8 upon 1.5 into 10 raised to power 8. These are the identical. This is a simple division of 3 and 1.5. Now we know the trick. One again. We write then 30 upon 15, 15, and answer is 2. What is the answer to this question? The refractive index of medium, the refractive index of medium with respect to vacuum. That is absolute refractive index. That is 2, no unit. Now the last question, B. If the absolute refractive index of glass and water, 2 things are given. So first of all, write down the data. That absolute, so N, but there are 2 things, glass and water. So G N V, V for vacuum. And this is 3 by 2. This is given in our book in an example. Now refractive index of water, that is W and V, is given as 4 by 3. Now what we need? The refractive index of glass, G and W. This is what we need. Now first of all, we clarified what we need exactly. What is G and W? That is velocity of light in water upon velocity of light in glass. That is exactly what we need. So this is our motto. To find the solution, we need velocity of light in water upon velocity of light in glass. First of all, we write G and V, the absolute refractive index of glass. So this is velocity in vacuum upon velocity in glass. and this is given as 3 by 2. Call this as equation 1. Now secondly, we have given absolute refractive index of water, that is VV, means velocity of light in vacuum upon velocity of light in water, and that is given 4 by 3. Call this as equation 2. Now in further discussion, does not consider these two left sides. Now concentrate on this much part. Using these two part, how will you get VW by VG? Observe here. If you divide equation 1 by 2, then we get this fraction. So we write here dividing equation 1 by equation 2. So equation 1 is velocity in vacuum upon velocity in glass upon the left hand side, velocity in vacuum upon velocity in water. Now right hand side, 3 by 2 upon 4 by 3. Now we simplify. Now observe here, we have to divide this fraction by this fraction. Now when we divide by fraction, division means the multiplication by its inverse. So how will you do this? Observe here, velocity in vacuum upon velocity in glass. So for this division we write multiply and then inverse. Inverse means V velocity in water upon velocity in vacuum. Now on parallel lines, division means multiplying by its inverse. So what is the inverse of 4 by 3? 3 by 4. The two terms V are identical, they cancel. So V by W upon Vg. Now here in the numerator, 3 3's are 9. So this is 9 upon 4 2's are 8. Now if you observe carefully, this is nothing but the definition of refractive index of glass with respect to water, the right hand side, and that is 9 by 8. So in this way we get the answer that refractive index of glass with respect to water is 9 by 8. This is the final answer.